In this lecture, we'll talk about the inverse of Laplace transform. First, continuous functions with identical transform theorem. Well, suppose that we have two continuous functions, g of t and f of t, right, where for all t is non-negative. And if we know that the Laplace transform of f is the same as the Laplace transform of g of t, then the function f of t is the same as a function of g of t. Okay. In other words, a continuous function can be uniquely recovered for its Laplace transform. And the inverse Laplace transform is also a linear operator, which means if the inverse of alpha g plus beta h equals to alpha the L inverse of g plus beta L inverse of h of t. Again, this theorem says that if you have a Laplace transform of the function, you can find a unique function that corresponds to that Laplace transform. So that will help you make sure that there's only one original functions that will corresponding to a given Laplace transform. Okay. Well then, let's try to practice on how to find or how to recover the function f of t given its Laplace transform. So if k of s here is a Laplace transform of the functions k of t, little k of t, find little k of t. Okay. Well, if we look at this k of s Laplace transform, this is a form of the function t, a power function, right? T, where the power is 1. Okay. And 9, it is a constant. So you can recover 9 over s squared is 9 times t to the 1. It is because, remember, if a function f of t equals to t, then the Laplace transform equals to 1 over s squared. Okay. And 1 over s squared is here, and then you multiply by 9, you can just have it here, and you can just have it here. That's how I think about inverses of Laplace transform. Okay, so I recover these functions. How about these functions? 12 over s minus 4. So 12 is just a constant. I move it out. 1 over s minus 4 reminds me of functions e to the alpha t, where alpha equals to 4t, right? Alpha t. And alpha equals to 4, so my function is just going to be e to the 4t. Okay, which is the function k of t equals 9t minus 12 e to the 4t. If you don't trust your instincts, you can try to find the Laplace transform of these functions to see if it's the same as these functions here. For the second example here, you have 2s plus 3, s squared plus 16. So the s squared plus 16 looks like sine or cosine, right? This is 4, 16 is 4 squared. So it's going to be sine 4t or cosine 4t. So in the sine, you have like 4 over sine squared, right? Sorry. If it's sine, then you have 4 over, no, 16. 4 over s squared plus 16. If it's cosine, then you have s over s squared plus 16. So you have s and you have a constant. You can combine them, right? That means, and then I have s here, I have a constant here. Somehow I can connect this to this and connect this to this. Okay. Well, let's rewrite this. This is the form that I want to see in order to convert this into cosine and sine. So I can rewrite this as 2s over s squared plus 16. plus 3 over s squared plus 16. Okay. Well, 2s is simple. In order to have s over s squared plus 16, I just move the 2 out here. So I extracted the correct form for cosine. How about the correct form for sine? I have 4. I have 3, but I need a 4. That means I need to multiply by 4 here and multiply by 4 here, the top and the bottom. So then I can extract the correct form for sine. Okay. And then the constant would be just constant, multiple constant. That will be simple enough. So moving on to the next step, I will have now 2. This is cosine of 40. This is 3 over 4 of sine of 40. So this is how I find the inverse of this Laplace transform. I recover the original functions, small f of t. Okay, but I recognize the pattern and trying to come up with the correct form, so then I can use this form to convert it back to the original function. How about the next example here? So look at the pattern. I have s plus 2 squared plus 12. But instead of have s squared, I have s plus 2 something. So that reminds me of this formula. S minus alpha, and then you have e to the alpha t times a sine or cosine functions, right? So if you have this form, so you think about e to the alpha t sine beta t, right? Or e to the alpha t cosine beta t. So what is alpha? Alpha, s minus alpha, that means alpha is -2. What is beta? This should be beta squared. That means beta equals to square root of 12 is 2 square root of 3. Okay, so I can replace beta and alpha by -2, -2, 2 square root of 3, 2 square root of 3. Okay, and then this case right here, if I have this functions, then the correct form for the Laplace transform should be, look at this tables here, s minus alpha for cosine and just beta for sine. Beta, which is 2 square root of 3 over s plus 2 squared plus 12. And this should be s minus alpha, which is -2 plus 2 over s plus 2 squared plus 12. Okay. How can I extract these two correct form from here? You will have, again, you have s here and you have constant. So you want to break it down into two different fractions. Okay. And look, I need to have s plus 2, but I only have s here. So then I can put s plus 2 here. So I have 2s plus 2 plus 4. I have 2 minus 4. Okay. Well, let's do it first then. I should put in the correct form first before I break it down into two different fractions. see if it's gonna be easier for you. So I have s plus 2 here. I need 2, so then it's 2s plus 2, and I added 4, so I have to subtract 4, so then it's gonna be equivalent, and I plus 2 plus 3, right? 3 is here. Again, I'm not doing anything fancy with it. I'm just playing around, so then I will have the correct form to work with. Does that make sense for you? If you simplify that, it's gonna be 2s plus 3, right? But because I'm doing it here, so then I can have the correct form here. So I can, so -4 plus 3 is gonna be just -1. So this will be 2s plus 2 over s plus 2 squared plus 12, and minus 1 over s plus 2 squared plus 12. Okay. Well, the first fraction here is in the correct form already. So I just extract it, put it here. But this one right here, I need 2 square root of 3. So that means I just need to multiply 2 square root of 3, and I also multiply 2 square root of 3 in the bottom, just to extract the correct form. Okay. Now I have, this is e to the -2 times e to the -2t cosine of 2 square root of 3t minus 1 over 2 square root of 3 times, this is the form of e to the -2t sine of 2 square root of 3t. This should be my final answer for the original functions that correspond to this Laplace transforms. So as you can see that we're just doing things reversely this time. Previously, we learned how to convert a function into its Laplace transform. In this sections, we learned how to recover the original functions using its Laplace transform. It's not anything fancy here. We just need to get used to all the formula. We just have to be able to recognize what functions that correspond to any of these functions here, to do more practice, and then you'll be comfortable with this topic.